And welcome back. As we continue looking at polymorphism, today we're going to talk about the final modifier and a little bit more look at how late binding actually gets used within our classes. So when we talk about the final modifier itself, this is a way for us to mark a method to indicate that it cannot be overridden with a new definition within a derived class. We simply do this by adding the final modifier to the method heading as in the following example, public final void some method. Now, final is not simply restricted, though, to methods. An entire class can technically be declared as final, in which case you cannot use it as a base class to derive any class from it. Once you say that class is final, that's it. No deriving from it. Now, the syntax, of course, for a class to be final is illustrated as follows: public class or public final class, some class. So if a method is marked as final, it means the compiler can only use early binding with that method. We can't use late binding, which enables the compiler to be more efficient. However, that added efficiency is normally not that great, and it's more recommended that the final modifier be solely used for reasons of efficiency. Also, when we start getting final involved, it can sometimes aid in security to mark certain methods as final. So there are some perks to using final, but there's also times when we don't need it. Now, that gets us back to, of course, we just mentioned binding. Here comes late binding. Again, here we are. So, if we want to view the final modifier as a way of turning off late binding, or whether that's for a method or an entire class, it does do a little bit more than shutting off late binding. It actually turns off the ability to redefine the method in any descendant class because it's final. It's the last version. If you add the modifier final to the definition of a method, it indicates that the method may not be redefined within a derived class, as we've kind of already have talked about. Now, if we add the modifier there to a definition of a class, it indicates that it can't be used as a base class. All right, so again, same things we've already seen earlier, but it's just good to keep this fresh in our mind. So let's actually look at this now with a late binding example. Let's actually start using some of this late binding that we've been talking about. Suppose we're designing a record keeping program for a parts store. And it can be any kind of parts store that you want. Let's just say that we are. Well, we want to make that program versatile. All right, but we're not sure we can account for every possible situation. So for example, let's say we want to keep track of sales, but we can't anticipate all types of sales. So we might just have regular sales at first, which is fine. But later we might have things like discounts or mail orders or web coupons or something like that. Might have a different factor of how all these things kind of work together. Now these sales, of course, will be for an item with a basic price and ultimately will produce some bill. For a simple bill, the bill is simply just the basic price. But later if we add discounts, then those bills are also going to depend on the size of the discount. So when we start saying, like, well, we've got all these things, how does that affect our program design? Well, the program needs to be able to compute, let's, for example, say daily gross sales. How much money are we making? Which intuitively should just be the sum of all the individual bills. Well, we may also want to calculate, for example, let's say, well, what was our largest sale for the day? Or what was our smallest sale for the day? Or how much did we make on average per each sale? Now, all these, of course, can be calculated from individual bills, but many of the methods for computing the bills will not be added until we kind of look at the program later when we decide what type of sales we want to be dealing with. Now, because Java uses late binding, we can technically write a program to total all the bills, even though we don't necessarily know the code for some of the bills yet. And we're also just going to assume for what we're talking about today, for simplicity, we're going to assume that each sale that we're doing is just for one item rather than a multi-item sale. So if we look at our code for sale, all the types of sales will be derived classes of the class sale. The class sale, of course, corresponds to simple sales, a single item, no added discounts, no added charges. And we have two methods called less than, and both include invocations of the method's bill. Now, we can later, of course, define derived classes and define those methods, and the methods less than and equals deals will be the version of the method bill that corresponds with the object of the derived class. And with our discount sale code, we have different definitions for the version of that method. Now, the methods less than equals deals, which are inherited from sale, you'll notice that they are used with the object of the class discount sale, all right, which means that that definition is operating on the one with discount sale, not with the base class. And what that works out is that late binding within discount sale is actually helping us out here. So, for example, if we call D1 dot less than D2 for objects D1, D2 class, so they're both discount sales, the method definition less than is going to be given in the definition of the base class sale, which of course was compiled before we even thought of discount sale. Yet the method called D1 dot less than D2, the line that calls the method build knows enough to use the definition of the method build given for the class discount sale. This all works because, again, Java uses late binding. And let's look at the demo here to see how that kind of works and how those are going to make a much more complete program than if we try to operate them individually. So here we are with our sale class, and you can see in here we have a couple different things. Of course, we have our basic structure in here, we have our constructors, we have our get methods, our set methods, awesome access mutators, toString. But here's that bill method we talked about. When you look, it says public double bill return price. All right, no problem. Here's the equals deals, so you can look and see here's how this one operates. And here's our less than. And if we go ahead and pop over to discount sale, we can see we have a similar structure here, but you can see that double bill is now overridden here. We give it a new definition here. So now it's double fraction is equal to discount divided by 100, return 1 minus fraction times get price. And we, of course, have this changing what we had originally here in sale. Because remember, sale, when we looked at bill, it was simply just return price. So they do have a little bit of a different thing. So if we look at our late binding demo here, we of course are say, hey, we got a sale object here. We're going to make a floor mat. Cool. Let's sell that floor mat for $10. No problem. Well, let's go ahead and make a discount sale. All right. And we say new discount sale floor mat. It says $11, 10. It says this is one item at $11 with a 10% discount. And let's just go ahead and print out the two items here. And we're going to say, hey, you know, if this discounted item is less than the sale item, we're going to say this is cheaper. Otherwise, we're saying it's not cheaper. And then if we look, we have a cup holder here. Then you can see how these work here. He's got $9.90, and this is the same thing here. And of course, we are comparing those. So these are going to work through with the late binding here. Because if this, again, used early binding, we wouldn't necessarily get the output that we might think about or might expect. So I'm just going to go ahead and run this program real quick. And you can see that we get the floor mat price and the total cost. And of course, we got the discounted one here. And you can see it says discounted item is cheaper. And then down here, this is our second run. We can get the deals are equal. So this is just a nice way to visualize. Again, a lot of this stuff that with late binding is things that we're already kind of familiar with when we're dealing with inheritance, because a lot of these techniques really kind of work together as a full mechanism for the programming language.